Okay, this is going to be the second video on the series involving how to do integration using partial fractions. And I would suggest watching the first video before you watch this one, and it will give you a little bit of an introduction into this. But the problem looks like this. Now, this is actually going to be a fairly easy problem because it's going to involve linear factors that don't repeat, in other words, distinct linear factors. And also, this problem is not going to have any use substitution. Some of the problems actually have use substitution. Now, the first step on all these is always, if you've got a rational function, make sure that the degree of the denominator is less than the degree of the numerator. In that case, it is. If it was not, you'd have to use long division first. But our denominator is, the degree of the denominator is greater than the degree of the numerator, so we are good to go on this one. So the first step is go ahead and factor the denominator. So let's just go ahead and do that. So what we're going to have is this is going to be the integral of, and we'll go ahead and put the bar across here. This will all be in terms of x. The numerator is x plus 16, but in the denominator, we're going to factor that. So that'll factor into an x plus 4 times an x minus 2. So you've got the denominator factored. Now the next step is this, is to take this rational expression and break it down into two partial fractions. So let's go ahead and rewrite it right here. So this is going to be, I think I'll put that bar across here again. So we're going to go, say, from here to here. The numerator is still x plus 16, and the denominator is x plus 4 times x minus 2. And I want to break this up into partial fractions, so I'll put an equal sign right here. And again, the two partial fractions would be the following. The first one we'll put right here. And the first factor is x plus 4. It's non-repeating because this is just an exponent of 1 here. And also, it's a linear factor. So this is going to be x plus 4. And I need to figure out what this coefficient is, so we'll put just the letter a right here. Then plus, this is going to be, the second factor is going to be x minus 2. And again, it's a non-repeating linear factor, so I'll put a b right here. So what I've done in this step is to decompose the rational function into two partial fractions. Now, if you're not familiar with this part where you get the a and the b, let me back up and show you the rules that we used in the last video look like this. So in that last video, we went through and showed how to decompose something into partial fractions. And if it was linear factors, it looked like this. If it was quadratic factors, it looked like this. So I am assuming that you have watched that video and you're familiar with how to decompose it. If you're not, then you definitely need to stop this video, watch that previous one, and then come back to this one. So we'll go on from here. Okay, now what we've got is this, is you need to know what is A and what is B. And what you've got here, again, is a rational equation. It has denominators. So you want to eliminate the denominators to get it into an equation that doesn't have any denominators. So what we'll do, and the way to do this, is to multiply the whole through, and this is just an algebra trick, multiply the whole thing through by the common denominator. And in this case, the common denominator is x plus 4 and x minus 2. So you multiply each term by the common denominator. So I'm going to multiply this term by x plus 4 times x minus 2. Whatever you do to one term, you've got to do the same thing to all the terms. So again, multiply this one by x plus 4 times x minus 2. And then finally multiply this one by x plus 4 times x minus 2. Okay, now again, the whole reason for doing this is just to get rid of the denominator. You want an equation that doesn't have anything in the denominator. So let's see what that does for us. Now, we'll rewrite it on this term right here. The x plus 4 here cancels out the x plus 4 here. X minus 2 cancels out x minus 2. And you're just left with x plus 16 is equal to, now on this one, x plus 4 cancels out the x plus 4. And you're left with a times x minus 2. Then finally, you've got plus. Now here, the x minus 2's cancel out, so that x minus 2 will cancel out that x minus 2, which leaves you with b is equal to x plus 4. So what this is the basic equation now that you have to solve, and you need to solve for a and b. Now, at first, it looks like you've got a problem because you've got one equation with what seems like three unknowns. X is unknown, A is unknown, and B is unknown. Now, you get to pick whatever X you want to. So the trick on this is to pick a value of X that will make either A or B, this term or this term, go to 0. So first of all, let's try this. Suppose, and we'll scoot this down just a little bit here. Suppose that we decided to solve for A. So let's put a, right over here, we'll go to find A, then we will let X equal, now the question is, let X equal what? Well, if you define A, you want this B term to go to 0. So if you were to let X equal a -4, then you'd have -4 plus 4. This term would go to 0 because B times 0, the whole thing goes to 0. So to find A and make B go to 0, let X equal a -4. It's your choice what you pick. So I'm going to let X be equal to a -4. Okay, so now that you made that decision, look back at this equation, and in this thing right here, we'll underline the whole thing. So this entire equation, just everywhere you've got an X, plug in a -4. So that's going to give me a -4 plus 16 is equal to A times a -4 minus 2 plus B. And here you're going to have a -4 plus 4. So when you plug it in, it does that. Now what that's going to do, it's going to do exactly what you want it to do. You're trying to get rid of B, so -4 plus 4 goes, this thing right here goes to 0. 0 times anything goes to 0, and this whole term disappears and goes to 0. So what that leaves you with, -4 plus 16 would be 12, and then you've got A times -4 minus 2 would be -6. So just divide, and you'd have 12 divided by -6 is equal to A, or -2 is equal to A. So now you know what A is. So we'll put a little dividing line here, and now we want to find B. So we'll use the same logic. So to find B, now this time we want A to go to 0. So this time, again, your choice, I'll let X equal, and let X equal whatever it takes to make this term go to 0. So in this case, if you picked a +2, that would be a great choice because 2 minus 2 would be 0. So in this case, we're going to let X equal 2. And then just repeat the process. Starting with this equation, just everywhere you've got an X, plug in a 2. So this would be 2 plus 16 is equal to A times 2 minus 2 plus B times 2 plus 4. So it looks like that. Now again, what you were hoping for is this time you wanted the A to disappear. So sure enough, 2 minus 2, this is going to be 0, and A times 0, this entire term right here will go to 0, which is exactly what you wanted. So now add these together, and you get 18 is equal to B times, and then 2 plus 4, this would be 6. So 18 divided by 6 is going to be equal to B, and 3 will be equal to B. So now you know what A is and you know what B is. So if you look back up at your equation here, what you've got, and I think we'll go ahead and put them in blue just to make them stand out. Instead of A, you've got a -2. So this is a -2. In place of B, you've got a 3. So you can rewrite this partial fraction that looks like this. So let's go ahead and do that down here. So we'll go ahead and rewrite kind of the whole thing. This is going to be the integral of, and the original problem was X plus 16, and we factored it into an X plus 4 times an X minus 2 whole thing dx. And now you've showed that that's equal to the integral, and using this right here, this would be minus 2 over X plus 4 plus, this would be 3 over x minus 2, whole thing dx. So now it's just a matter of solving this. And a couple ways you can do it. Some people like to leave it as a single integral, or you can split it up into two integrals. I think what I'll do is go ahead and split that into two integrals. So I'll make this be the integral of minus 2 over x plus 4 dx plus the integral of 3 over x minus 2 dx. So I'll just split it up into two integrals. Okay, now the next thing, I want to find those integrals. And again, I've got a constant here, so on both these I'll factor out the constant, which leaves me with this. This is going to be minus 2 times the integral of 1 over x plus 4 dx. And then in this one, I'll factor out the 3, so I'll have plus 3 times the integral of 1 over x minus 2 dx. Okay, now to solve these integrals, hopefully this is the form that you recognize, but let's just kind of look back up here. And you may remember some work you've done in the past is this falls into this form right here. You have a form that the integral of 1 over u du is equal to the natural log the absolute value of u. So 1 over u turns into the natural log of this. And let's go ahead and we'll scoot that down just a little bit where we can keep it in front of us. So we'll move it down, say, to right here. Okay, back to our problem. Now, the next question is, do you need to use u substitution on this? And you might remember when you did these problems previous in the course, as long as this is just a simple x right here, then you did not have to use u substitution. Now, if this was something like 3x plus 4, you would have to use u substitution. But it's a simple x, so in this case, we can get by without u substitution. So this will just turn into using this rule. First of all, here's the constant negative 2. And then the integral of 1 over this turns into the natural log of that. So this will turn into the natural log of the absolute value of x plus 4. And actually, there'd be a plus c here, but we'll combine those into just a single plus c on the outside. Then you've got 3, and this will turn into the natural log of the absolute value of x minus 2. And then you can combine both the constants and just put them as a single constant plus c, and you'll have an answer. So once again, just to run back through the problem, and I think I'll go ahead and take this and scoot it over here. Let's move this back like this to the top. Okay, starting from the beginning, again, factor the denominator and use decomposition by partial fractions to break it up into this. If you're not familiar with it, again, you may have to review these rules to remind yourself how to break it up. Then it's just a matter of solving for a and b. So once you've got it broken up into partial fractions, multiply through by the common denominator. That will remove all the denominators, and it gives you a basic equation. And I think we'll go ahead and put that real quickly in red. So you'll wind up with this basic equation right here. Okay, once you've got the basic equation, then to solve for a or b, pick a value of x that will make either a or b disappear. So if you want to solve for a, pick negative 4 because b will go to 0. If you want to solve for b, pick positive 2 because a will go to 0. And then you'll have a and b. Then, once you've got a and b, it's just a matter of running through the integrals. So you can split it up into two integrals and use the rule for natural log, integral involving 1 over u, turns into natural log, you'll have this and you'll be done. Now this problem, and I think I'll go back up at the top one last time, it had linear factors, none of which repeated. They were distinct linear factors, and no u substitution. Now, in the next videos, we'll look at problems that have repeating linear factors and involve u substitution. So the problems get a little bit trickier, but it'll be more or less the same process.